Thank you for joining. In this lesson, we will explore what a schema is, how to apply it to a database, and how to insert or ingest data into the database. First, let's describe the schema. I will not read you the official schema definition, instead I'll explain it to you using an analogy. Think of a schema as a filing cabinet in a large library. The library represents your database, containing a variety of books which are objects. These books are stored in different filing cabinets, each of which corresponds to a schema. Each filing cabinet or schema is labeled with a specific category or topic, such as history, science, or fiction. When you need to find a particular book or object on a specific topic, you navigate through the library, heading directly to the relevant filing cabinet or schema. Inside that cabinet, you will discover all the books and objects related to that topic neatly organized. This method enables you to quickly locate the materials you need, without having to sift through the entire library. So in the context of a database, schemas help you organize and access specific groups or objects related to particular categories or topics. You pass through the schema to access the objects you want to see, just as you pass through a filing cabinet to find the books you are interested in. When you start SQL Server Management Studio, you will encounter the login prompt. Upon entering your login credentials, you gain access to the SQL Server instance. And this instance appears at the top of the tree in the Object Explorer. From there, you can create databases. Once a database is created, you can use schemas to define its structure. After that, you can populate the database structure with your data through actions like ingesting data or simply filling in tables and other elements. Now let's practice. For this lesson, you can download any database you prefer. Just search for sample SQL databases and you will find numerous links. I found a sample database that works well. After downloading the archive and unzipping it, you will obtain 3 files. The first file contains commands to create the schema, while the second file contains commands and data. Using these commands, we insert data into the database in accordance with the schema structure from the previous file. This file facilitates data ingestion. The third file, on the other hand, drops data and schemas, effectively erasing all the tables and the data they contain. As a result, the database will be emptied, leaving it like a freshly created brand new database with no data. This can be useful when you want to start with a clean slate or remove all existing data from the database. If you download another sample database, it's possible that the files are combined, and with a single file you can achieve the same result as using these 2 files for schema creation and data ingestion. However, this approach with separate files is more illustrative, as it allows you to see all the steps separately. After unzipping all the files, let's open the first one with the suffix create objects. Inside, this file contains schema creation and table creation commands, which we will explore in detail in the Transact SQL chapter of this course. Now let's focus on what this file does when executed. The first 2 commands define schemas. This file defines the structure of database objects, such as tables and relationships within the database. The script itself is not tied to a specific database and can be used to create these objects in any database within the SQL Server instance where it's executed. You can think of the script as a template or blueprint for creating the database structure. You can use it to create tables, schemas, and relationships in a new or existing database, and the actual database name is determined when you execute the script in the SQL client. So you can reuse the script to set up the same structure in multiple databases if needed. In SQL Server, when you execute a script that creates schemas and tables without specifying a database, like this one, these objects are created in your current database context. There isn't a temporary storage area where these objects are held before being applied to a database. They are created directly in the database. Now let's open the second file. This file contains all the data for the database, and the very first string says use bike stores, which means we should have a database named bike stores to inject this data into it. The first file will structure the bike stores database or any other database, and the second file will ingest the data into a specific database. So let's create a database and name it bike stores. And you can copy this name from the second file to ensure it matches the request in the downloaded file. The database is now ready. The next step is to execute the file that creates the schema. on the bike stores database, press F5, and it will create schemas and tables within the current selected database. After the command is executed, if we open the bike stores database, we will see all the tables created, although they will be empty. This indicates the command was successful and the structure is ready. The second step is to inject the data into the database. And using this second file, which contains all the data structured in accordance with the schema, we can fill up the database with this data. Let's run it. If we access the database now, instead of empty tables, we will find numerous data fields that were provided when we executed the second file. And the third file will erase everything we just created. Let's go ahead and run this file to reset our database. Now the database is empty. I will quickly recreate the database to use it as an example for this lesson. Let's start practicing with queries. If we right-click on the table, we will see a menu with an option to select top 1000. When this command is executed, we receive the requested data. Using SSMS, this command was executed on the database safely, requesting the first 1000 records. Safely means that even if we have thousands of records, this command won't overload the system. Additionally, we can modify this command and, for instance, request the top 5 records. Now we get the requested 5 records as the result of the executed query. The square brackets can handle reserved words, special characters including spaces, and case sensitivity if necessary. However, we can remove them, and the query in this specific case will work the same way. We will delve into these topics later in this course. If I remove the reference to the database, then we need to explicitly specify which database we are referencing in our SQL commands. Using transact SQL, we can use the use statement like use bike stores. The use statement in SQL Server allows us to specify the database context in which subsequent queries or statement will be executed. It's used to change the current database for this session. So this command now indicates that the query will be executed against the bike stores database. Additionally, we can use the go statement, which allows us to execute different parts of the query as separate batches sequentially. If you need to execute a specific part of the query, you can select the required part while holding down Ctrl and Alt, and then press Execute. Or you can right-click and choose Execute. I will simplify this query. And for the other part, let's comment it out using the shortcut Ctrl-KC. And to uncomment, you can press Ctrl-KU. You can make it a one-liner, and it will still work. The only difference is in readability. Currently, it's readable, but as the query grows, it may become an issue. So it's better to format it this way, and we can include the proper indentation. There will be no difference if you use lowercase commands. The language will work without any changes. However, it depends on the project's naming convention or naming standard. The only impact that lowercase commands have is on the readability of the commands. If you are a beginner, it can be challenging to distinguish between the command and the query parts. I will primarily be using capitalized commands during this course. If you need to split the results, you can use two queries. First, select the required query, then press Ctrl-D to duplicate it. You can then modify it to provide 20 records, and when executed, you will get the results for both queries. To save the query, click on the query window and select the path where you want to save it. You can read the saved file with any text editor. As you remember from the previous lesson, the query is just text. Similarly, you can update or create a query directly in a text editor and then execute it in SSMS. Additionally, this type of command, using an asterisk to indicate that we want to select all columns from the table, can be a convenient way to quickly retrieve all the data from a table when you need all the columns. However, there are some considerations to keep in mind. The main one is performance. If the table has a large number of columns or contains a substantial amount of data, selecting all columns with select asterisk can have a performance impact, especially if you only need a subset of those columns. Retrieving unnecessary columns can lead to increased network traffic, high memory usage, and longer query execution times. Therefore, please always remember to retrieve only the information you require. Moving on the comments in SQL Server Management Studio, there are two types. The first one is single-line comments. These are used to add comments or explanations on a single line of your code. Single-line comments are declared using double hyphens. Anything following the double hyphens on the same line is treated as a comment and is not executed as code. And the second type is multi-line comments. These are used to add comments that span multiple lines of your code. In SQL, you can enclose multi-line comments between slashes. Everything between these delimiters is treated as a comment and is ignored when executing the code. Multi-line comments are useful for providing explanations, notes, or context for different parts of your SQL scripts. If you need to format your code, you can select the required part. Then right-click and choose Design Query in Editor, or use the shortcut Ctrl-Shift-Q. In the next lesson, we will connect the database to Visual Studio and send a query. Thanks for watching. If you have any questions or need further assistance, feel free to comment below. Don't forget to hit the like button and subscribe to our channel for more great coding content. Stay updated with the latest videos by ringing the notification bell. Happy coding!